So before we get started on what we're doing today, I want to, you don't have to write this down, but I had a question yesterday. It was a good question, and this applies to way more than just this, but the geometric series that we talked about yesterday, the formula that I gave you was this. We had, let's see, A1 times 1 minus r to the n over 1 minus r. Okay, so the question that someone asked me, well, really more so than they pointed out, but in Delta Math, that's not the formula that they show you. Okay, I don't know if you noticed that. You may not have even noticed that. But what they show you in Delta Math is this. A1 minus A1 r to the nth power over 1 minus r. Is that the exact same thing? It is, because all they did was distribute this one right here, and that it's the exact same thing. It's just in a different form. So that's why sometimes I say, we're using this, but depending on what formula chart you look at, it may look different. They're literally the exact same thing. You just put stuff in a different way. So even with what I'm giving you today, there's another way you could see it. It depends on who's showing it to you and what they prefer. One's really not better than the other, but sometimes you will see things a little bit different, but it doesn't mean that, you know, one's better than the other. Pick the one you like the most. I don't really care. As long as you get it right, you're good. Okay? We good on that? All right, so let's look at infinite geometric series. Okay. So, let's think about that. Series means that we add up all the terms, right? If it's an infinite series, it means we're using an infinite sequence that we're going to add up. Can I physically add up an infinite amount of numbers? No, I can't, because I would never finish, right? Because you just keep going on and on and on. But we will actually be able to get a sum for some of them. Let's look at how that works. Okay, so we're going to start by taking a couple of these sequences, and we're going to find partial sums. And you don't have to type these in. I'm just going to give them to you because it'll just be way easier this way. So if I find the sum of just the first term, well, the first term's 1/2, so it's going to be 0.5. The sum of the first two terms would be 0.5 plus 0.25, so that's 0.75. Right? And then we would get 0.875, and then we would get 0.9375, and we get 0.96875, we get 0.984375, and so forth and so on. Okay? So for the first few terms, the sum changed quite a bit, but then the farther you go along, it's going to change less and less and less, because the farther you go on, your fraction values get smaller and smaller and smaller, right? And if we actually wrote out an infinite number of those fractions, we would never actually get there, but those fraction values would get really, really, really close to 0, right? Which means that I keep adding less and less and less to this. The sum of an infinite amount of the terms in this sequence would equal 1. So, a series that approaches a certain number, or a certain sum. So, we never actually get to 1, because we never actually get to an infinite amount of them, but we're approaching 1, and so we use the sum as 1. It is called convergent, a convergent series. So, if it actually approaches a number, which isn't always 1, but approaches an actual value, then it's a convergent series. All right? So, let's look at this one. If I do this, the first term is just 0.5. Then I add 1 to that, I get 1.5. Then I would get 3.5. Then I would get 7.5. Then I would get 15.5. And then I would get 31.5. Okay? And so my numbers are getting bigger and bigger and bigger. If I keep adding them, what do you think this is going to approach? Infinity. Yeah, it's just going to keep getting bigger and bigger. So this sum, I'm not going to say it's equal to infinity because it can't be, but it's approaching infinity. So a series that does not have a certain sum, because infinity is not a number, that's divergent. So being able to determine if a sequence or a series rather is a convergent or divergent is important. Mr. Ackerman was very excited that I was doing this lesson today, so something that you need to know. So let's look at how we can decide that. If R, remember that's your common ratio, right? If the absolute value of R, so it doesn't matter if it's positive or negative, if it's less than 1, then the series is convergent. If the absolute value of r is greater than 1, then the series is divergent. So if it's less than 1, that means it's a fraction. So my values along the sequence are going to get smaller and smaller and smaller. And that's why we get to actually converge on a number. If r is greater than 1, then my numbers get bigger and bigger and bigger, and it'll make it to infinity every time, but infinity is not a sum that we get to use. Okay? So we have to determine whether or not they are convergent or divergent. If they're divergent, we can't do anything with it. If it's convergent, then we actually have a formula for that. Okay, so to find the sum of a convergent infinite geometric series, we would have S equals A1 times 1 over 1 minus R. And I didn't look to see what delta math used for this, but another way you could see this is just A over 1 minus R, because if you multiplied, that's what would happen. So either way, it's fine, doesn't matter. Okay, easy enough? All right, so we're going to determine. It says determine if the series is, well, this says convergent. I don't even know. It should say convergent. I didn't catch that. Convergent or divergent. If it's convergent, then we find the sum. All right, so if I determine whether or not it's convergent or divergent based on R. What is R here on number 1? -6. Good. So if it's -6, is it convergent or divergent? Divergent. Okay. And that means that my sum actually does not exist. Doesn't really equals does not exist, but if you were told to find the sum, it does not exist. Easy enough? All right, so let's look at number 2. What is R here in number 2? 1/3. So is it convergent or divergent? Convergent. Okay, and then this is my first term, right? So my sum is equal to 72 times 1 over 1 minus 1/3. And notice the sum doesn't have a little subscript on there because it's the sum of all of them, so we don't need a number there. Type that in, tell me what you get. $108. Any questions at all? All right. Let's look at number 3. Okay, what is R in number 3? 3/4. That's your R right there. So is this convergent or divergent? Convergent. Which means we can find the sum. What's your first term? 224. Good. So the sum then is equal to 224 times 1 over 1 minus 3/4. What do you get? Good. 896. Any questions? All right, then y'all do number 4. Okay, so on this one, I know sometimes y'all are unsure about when decimals are okay, when it has to be a fraction. It gave me decimals. We're using decimals, so a decimal answer makes sense here. which would be 37.5. If I had gotten something on number 3 that wasn't a whole number, then that should be in a fraction because this was in fractions. Okay? We good with that? Any questions? Okay, here's the deal with your assignment. It's in Delta Math. But for some of the questions, and I don't think all of them, even if you have it 100% right, it's counting it wrong. I cannot figure out why. So if you typed it in, like, it'll show your answer and the right answer. If they are literally the exact same thing, just don't worry about it and move on because that's going to happen to everybody. I'm more concerned about whether or not you know that you know what you're doing or not. Make sense? So just don't stress out if the grade I'll look at the completeness instead of the grade on this one because I thought maybe it was something I can't figure it out for anything. So, if that happens, maybe it happens on all the questions for you. Maybe it only happens on some of them. Just go with it and just keep moving on. Okay? We good?